Hello, in this video, I want to demonstrate how you can use the EPiC plugin to conduct lifecycle assessment of a building assembly. Um, well, I modeled a parametric double-layered wall with insulation in between. So it's a stud wall with insulation between and the cladding inside and outside. Now I want to show you how you can conduct life cycle assessment for this wall panel, for this wall assembly. To get started with, I will just show you how to set the script to run lifecycle assessment for just one single layer of the wall, and then I'll show you how to consider the entire layers and conduct the lifecycle assessment for the whole building assembly. So to get started, you should first create the geometry. In this model, I actually created solid matters. So I mean that this layer is basically extruded, is an extruded profile, which is the thickness of this cladding. And I created this through, of course, a parametric model. You can actually create this thickness in Rhino viewport and transfer and extrude it and transfer that geometry through a geometry parameter in Grasshopper. Then when we get to EPiC, you'll see that there are like three main palettes. One is the materials, which you can drop an EPiC material component, and as you see here, and then you can search through the inventory of the materials and pick the appropriate one. Or if you want to define a very specific or newly developed material, you can provide the specification of that material in terms of, for example, embodied energy coefficient and the units and density, and continue with that. So you can actually work with new materials as well. But let's just stick to the material library in EPiC. And then also there is another set of palettes which let you assign materials to the created geometry. And that is, and you can see a list of EPiC assembly definitions. You can define a material for a line, for a surface, or for a solid matter in Grasshopper. And at the very end, there is a component which is EPiC built assets that we'll use that when we want to consider multiple of layers within an assembly. We'll get to that later. And then finally, it is the EPiC analysis, which you can compute all the embodied carbon and embodied water and embodied energy of a particular material or a particular assembly. So to get started, you can drop, since here I have a solid volumetric geometry, I will drop EPiC assembly, and then you'll get this component. It asks for the assembly name. I drop the exterior cladding. Then it says, what is the category? So you may have like multiple different assemblies in a project. It might be walls, roof systems, or like floor systems, or furniture or landscape. It can be anything. So I just keyed in exterior wall as a category for that assembly. And then it asks for the selected volume. So now you need to connect the geometry. So I connect this geometry to EPiC input. What is important here to know is that you should connect VREP inputs to be able to run this volumetric EPiC assembly. if for any reason you don't have any BREP, you may see that you will get an error. Well, in later I'll show you, for example, here I have an extruded box. I just created one of these parts as a box, so it's not a BREP. You can just simply drop a BREP parameter and just connect that box to the BREP, and then Grasshopper understands that or reads that as a BREP, so no worries. Then at the next step, it asks for the material because EPiC wants to match the geometry with the material. Now you can connect that to the material component of EPiC. And when we get to the material component, first of all, you should drop a button, because when you click on it, then you can activate this component, which means that you are kind of connected to the EPiC inventory of the materials. And then you can use drop-down lists here from the parameter menu. You can drop value lists, and then when you connect it to the material category, you should pick which kind of a thing you want, checklist or drop-down menu or value sequence or value cycle. I'll go with the drop-down menu. But the easiest way actually is use the button native to EPiC. So let me just disconnect all of these to show you what would happen. When you drop the material component of EPiC, and then you drop this button, when you double click on this button, then you will see that these drop-down menus will pop up, and they're all connected to the material category and then the selected material. So we'll go with this. So first of all, we pick the right material. I want to go with a kind of like timber cladding, a sort of hardwood cladding. So you can just go through the list and see what kind of material you want. These are more sort of like generic material, like cork slab, hardwood, cross-laminated timber, so forth and so on. You may probably see a material or a product from a supplier or from department stores that you want to use that in your project. The good practice is to just search a little bit about that particular product and see if that type of wood cladding is considered to be a hardwood or it's a cross-laminated timber. So there are, thousands of products out there, but in some terms they're very close in terms of like mechanical and physical and chemical features. So you can see if, like, for example, that product is a hardwood air dried or kiln dried, is it structural or what? So I will, for example, go with hardwood air dried, and then what you need to specify is the wastage coefficient and the material life cycle years. Again, by referring to the product specification booklet, you can learn about the material life cycle. When you activate the EPiC material, you will see it is set to be like 50 years of material service life. If you're unsure about that value for your particular material, just keep it as default. But if you know that, which might be less or greater than that, feel free to set it as it is related. The wastage coefficient actually explains that what percentage of the material will be wasted during the construction and the assembly process. Again, the 5% coefficient factor is a kind of like common estimate. But if you're constructing an assembly that may reduce this amount of waste, like for example, 3D printing, concrete, or something else, then you may be able to reduce it. So then you can change this coefficient factor. By setting these two input parameters, then you're going to connect it to the material input at the EPiC assembly. Then the next parameter that you should specify is the functional unit of this geometry in per cubic meter. So here, since we're dealing with a box, every single cubic meter is equivalent to a cubic meter of wood. Sometimes it might be different. It might be, I mean, you may, particularly when you are like using surface assembly, you may just give the surface. So you have the area, but you actually didn't specify the thickness. And based on the thickness of that surface, that functional unit per cubic meter might be different. It depends on the density, also the thickness. We'll discuss that as we move forward. So for now, we can just see that every cubic meter of this cladding will perform as 1 cubic meter. Cubic meter. So now we set the assembly, and here you have a description of what you have set up. So you can see that what is the total volume of the object you connected, and then what is the material, and what is the embodied energy, embodied water, and embodied carbon of that particular material you connected, and then you can get the total. Also, there is another output here that is initial embodied greenhouse gas emission in equivalent kilogram of carbon, CO2, and that is actually 3 point something times 10 in the power of 6. Now you get the output. So if you want to like optimize anything, your project, you actually right now have the greenhouse gas emission potential of that particular material here, and you can use it. But if you want to get the graphs of embodied carbon calculations, you need to drop the EPiC analysis. So when you drop this, then you need to connect the EPiC assembly here. Since we just have one single layer, we just directly connect the EPiC assembly here. When we have multiple layers, we should first connect the EPiC assemblies to the EPiC built asset, and then connect the EPiC built asset to this. Then here it asks, what is the period of analysis? So originally, we said that this material has a life cycle of 50 years. And now we assume that we use that material to build a building, which will have an 80 years of life cycle. So within that life cycle, there will be a sort of renewal for the same kind of material. So now you'll see that this will increase the life cycle impact, the embodied carbon of that material. Also, here it says what should be the graph origin point. So if you want to have the origin point of the graphs that you want to get in your Rhino viewport, you can just give it a base point from which EPiC starts to draw the graphics. And also you can give it a scale that if you want like to get it large or small. And then there you go. you'll get this graph demonstrating the embodied energy, water, and greenhouse gas emission of that single layer of wood material. Now, in the next step, I want to show you what will happen when you want to analyze an entire assembly. So what I did, I provided separate geometries for separate layers, including the cladding, furring, actually the insulations and stud walls and wood sheathing. And then for every single geometry, I start to drop an EPiC material component, define the EPiC material component, and also drop an EPiC assembly, volumetric assembly, and give it a name. So I will call this assembly name an exterior cladding. It is also, I mean, I have just the same category of walls. This one is basically the cladding here. Then the next component will be exterior fairing. Then it will be the exterior sheathing. Then I'll define the studs, then thermal insulations, interior sheathing, and interior fairing, and interior finishing, and also interior painting. That is nice that you can do everything. So taking a look at the materials for the exterior cladding, I chose timber products, plywood for outdoor, and then I reduced the material service life cycle because it's a plywood. And the exterior fairing, again, I picked a timber product. I went with softwood kiln dry, and exterior sheathing by oriented strand board OSB sheets, basically because they are not like exposed outside, so you can just use for sheathing purposes and go with like cheap or let's say less expensive materials. And also for the studs, I used the same material that I defined for the fairing, the studs for the fairing. So oh, somewhere I had the studs. So they are like just coming from this geometry, and then here the material that I use for exterior fairing, I'm using the same material, but of course with different dimensions to define the studs. And then for thermal insulation, I went to the category of insulation, picked rock wool insulation. Exterior sheathing, again, the same kind of material, but it is a different geometry. And also for interior fairing, I use the same material I defined above. And for interior finishing, I just chose a concrete or plastic products category and used a plasterboard of 10 millimeters. And finally, for interior paintings, I explored the miscellaneous list and chose water-based paint per square meter. So these are the different materials. Now, what I need to do, I need to drop the EPiC building asset and connect all the different building assemblies I have here and give this a name. So here that is the exterior wall, and here are all the assemblies. Now I connect the EPiC building asset for analysis. Okay, then I'll set the life cycle of the entire wall assembly 80 years. And here you can run the analysis you can set the set point for the graphs and the scale, and now you will get automatically the graphics showing you the embodied energy, water, and greenhouse gas emission based on the different layers. So here you have an option. Here under the analysis, you have an analysis type. When you connect a button, you can load the different analysis types. So let me just disconnect this. So when you connect this button and click on it, you can play around with this. By default, you will get the total for the entire assembly, but you can pick if you want to get graphs by materials. So you can just see what are the embodied carbon or embodied energy of, for example, wood material or insulation. And actually here you will see that the plywood has the greatest greenhouse gas emission because you have the greatest volume of that kind of material. And plaster may have a great embodied carbon, but since we're just using it as like a thin layer, you'll see the total impact of this material is much less comparing to the other sets. You can actually see the analysis type based on the assembly, see which part of the building assembly has the greatest impact on the embodied carbon of the total assembly. Here it seems that the exterior cladding has the most impact. And also you can run the analysis based on the assembly and material both. And then you can get the graphics. So this is all about using EPiC assembly. I highly advise you to watch the video provided by the developer of EPiC and learn more about this tool. This is a very simple demonstration of how you can run the lifecycle assessment of a wall assembly while you model that as a volumetric matter.